Hello viewers, you are welcome to the Global Tutors YouTube classroom. My name remains Kehinde Abimbola Olushegun. We will consider the subject physics. And the topic is fundamental and derived quantities. Fundamental and derived quantities / units. In the last video, I made mention of three most important fundamental or basic units. And before I proceed, don't forget, like us and subscribe to our channel. Now I said I made mention of three most important basic units, which are mass, length, and time. And the units are kilogram, meter, and seconds, respectively. Now, I said that we have more than these three basic quantities. And the quantity mass, length, and time. They are respectively seconds, meter, and kilogram. We have more than these three basic quantities. The remaining quantities are number 4. Let's say this is 1, this is 2, this is 3. Number 4, we have amount of substances. Amount of substance, which the unit is in mole. Another one is electric current. Electric current, which the unit is in amperes. Amperes. You can denote it as A, and this one as MOL. Also, we have luminous intensity. Luminous intensity. And the last one, which is number 7. The last one, which is number 7, is temperature. Temperature. And the unit of temperature is in Kelvin. The unit of luminous intensity is candela. These are the SI units of all these basic quantities. And let me tell you one thing. In physics, we have numerous derived quantities and their respective units. But the most important thing is that as a physics student, you must make sure that you know all these 7 basic quantities. Because in question, like WAEC, NECO, and JAM, the examiner, they will not go beyond these 7 basic quantities at this level. And the smart way to attempt a question under this fundamental and derived quantities / units is make sure you master all these 7 basic quantities, and every other quantities, just assume them to be derived quantity. Let's take one question. For example, this is one of the JAM questions. This question says, which of the following? Question 1. Which of the following quantities is fundamental? And the options are option A, speed. Option B, acceleration. Option C, pressure. And option D, luminous intensity. Now, even if you don't know if speed, acceleration, or pressure, if they are derived quantity, but we are very sure that luminous intensity is a fundamental quantity or basic quantity. So our answer becomes luminous intensity. The other way around, let's take another question, for example. The other way around, the question may ask, which of the following quantities is a derived quantity? The option A, this is why question. The option A is velocity. A option is velocity. Option B is amounts of substance. Option C, length. And option D, electric current. Like I said earlier, that just make sure that you master all these 7 basic units. And even if you don't know that velocity is a derived quantity, but we are very sure that our amount of substance is a fundamental quantity, length is a fundamental quantity, and also electric current is a fundamental. So our final answer becomes velocity. This is the derived quantities. So this is the best way to handle question under these fundamental and derived quantities and units. Now we move on to dimension of physical quantities. Dimension of physical quantities. The dimension of physical quantities is what we use to determine if a particular equation in physics is right or wrong. Dimension of physical quantities. Dimension of physical quantities. Like I said, dimension, we use it to know if a particular equation in physics is right or wrong. So what is dimension? Dimension is an equation which expresses a physical quantity in terms of its dimension. An equation which expresses a physical quantity in terms of its direction. If I say physical quantities, we mean both fundamental and derived quantities. Those are the physical quantities. Let's take for example, don't forget, in the last lecture, I said that the 3 most important basic units are mass, length, and time. Under this dimension, we will make use of these 3 basic units, which are mass, length, and time. Now, in units, under unit, the unit of mass is kilogram, the unit of length is in meter, and the unit of time is in seconds. But under dimension, the unit of mass becomes the first letter of the quantity, which is capital letter M. The dimension of length becomes what? Capital letter L, the first letter of the quantity, and the dimension of time becomes capital letter T. These are the 3 dimensions of the 3 most important basic quantities in physics. Now, let me put dimension so that this is unit. This starts as units. and this is dimension. This is dimension. Now let's take for example, we want to get the dimension of speed. Speed, for example, let's get this dimension of speed, velocity, and acceleration. Acceleration. Now, the speed, what is the formula for speed? Before you know the dimension of speed. The formula of speed is defined as rate of change of distance with time. So distance, speed, our speed equals distance all over time taken. Distance all over time taken. That is, don't forget our distance is measured in length and also time taken using this time under this basic quantity. So we have distance is like, let's say, length all over time. That will give us L over T, and we write it like LT raised to power minus 1. That is the dimension of speed. Let's take the second one, which is the velocity. Let's take the second one, velocity. Velocity. Don't forget, before we can derive dimension of velocity, we must be able to define it and get our formula. And velocity is defined as what? Rate of change of displacement with time. Displacement, let's just write displacement. Displacement all over time taken. And don't forget that our displacement is measured in length, because displacement is like distance covered in specific direction. So our velocity is same thing as, let's say, length, because it is measured in length, and this one is measured in time, which is L all over T, and equals, we write it using one of the rules or laws of indices, L T minus 1. We notice that we have the same dimension for both speed and velocity. Why? Because they are the same thing, speed and velocity. The only difference is that one is a scalar quantity and the other one is a vector quantity. When we get to that aspect, we will discuss better. Now let's move on. Acceleration. Acceleration, that was the last one. Acceleration, that's the last one. So we define our acceleration as rate of change of velocity with time. Acceleration equals velocity all over time taken. Now we have derived our dimension for velocity. So let's just put it in this acceleration formula as LT minus 1 all over time taken is our T. So we have, using one of the rules or laws of indices, we have LT raised to power minus 1 minus 1 equals LT raised to power minus 2. And that is the dimension of acceleration. Then I said something the other time that we can use dimension analysis to know if a given equation is correct or not. Now we want to confirm that. Let's confirm that by, for instance, we know the equations of motion. We have equation of motion. One of the equation of motion, we have V equals U plus AT. We also have another one, which is S equals UT plus or minus half AT squared. We also have, lesson number 3, V squared equals U squared plus or minus 2AS. Let's stop at this. Now we want to know if this equation is dimensionally correct. How do we do that? Let's just use this example. You can confirm the other two examples. after treating this one with U. Now, V equals U plus AT. What does this V stands for? That is our final velocity. What does U stands for? It is our initial velocity. A stands for, okay, let me write it. V from the first equation, from, let's say, equation 1. Our V equals initial velocity. Our U equals, our V is the final velocity. Our V equals the final velocity. Our U is the initial velocity. And our A, which is the acceleration due to gravity, let's just write it as acceleration. And our T is our time. Now, we want to confirm if this equation is correct using dimension analysis. How do we do that? Don't forget that our V, we have gotten it in our previous derivation, that the dimension of V is, which is the velocity, is LT minus 1. And the same will go for U. So now if this is correct, then definitely the dimension of the left-hand side of the equation must be the same with the dimension of each of the parameter. That is, this is 2 parameters together. So we must have the same dimension here, the same dimension here, the same dimension here. So dimensionally, the equation is correct if they have the same dimension. Now we want to know if the dimension of V is also dimension of U. Now this is our initial final velocity, LT minus 1. And initial velocity will have the same dimension, because the only difference between U and T is that one is initial and one is final. Now we want to move on this other side of the equation, the AT. Now A is acceleration. Our A is acceleration. Thank God we have derived the dimension for acceleration before. And the dimension for acceleration is L. Let me just write from 80 now. 80. So dimension of A equals LT minus 2. And dimension of T equals capital T. Now, let's multiply the two. A times T will give us LT minus 2 multiplied by T. Using rules or laws of indices, we have LT minus 2 plus 1. Then we have LT minus 1. And that is the dimension of AT. If you look at the board, you can see that the dimension of AT is also the dimension of velocity, and it's also the dimension of the final and the initial velocity. So therefore, the equation of motion, V equals U plus or minus AT, is dimensionally correct. Now, let's check this work done. Let's check the dimension of work done. Because in questions like JAMB, WAEC, NECO, they may ask that which of the following options is dimension of work done. Then work done, a sample. Let's take it as a sample. Find the dimension of the following quantities. 1. Work done. 2. Momentum. And 3. Impulse. How do we get dimension of work done? First of all, I told you that you must be able to define your quantity and know the formula for the quantity. What is the formula for work done? You get the formula from the definition. Work done. Solution. Let's put solution. What is our work done? Our work done is the product of force times distance in the direction of applied force. Then leave the story. Let's just write our work done because we want to derive dimension of work done. So we just put in the formula. Work done equals force times distance. Force times distance. Force times distance. Now, you come to this place. From force times distance, we'll derive the dimension of force. Thank goodness that we know the dimension of distance already. Now, force. Then you now define your force. What is your force? You know that it's product of mass and its acceleration. Mass times acceleration, that is our force. And we know in the previous derivation, we have derived our dimension for acceleration. So therefore, our mass now is, we know that our mass from the basic quantity is capital M, and our acceleration is LT minus 2 because we have derived it before. So our force we have as a dimension of MT minus 2. That is the dimension of force. Now we want to, our work done become what? Let's say work done like this. Becomes what? Since it is force times distance, then we now have it to be MT minus 2. What is the dimension for distance? It is, the dimension for distance is L. Then what do we now have? We have ml square t minus 2. This is the dimension of work done. Dimension of work done using dimension analysis. The last one is momentum. Before we can derive the dimension of momentum, we must define it. Our momentum. Our momentum is what? Momentum is the product of mass and its velocity. Momentum equals mass times velocity. That is our momentum. And don't forget, we know the dimension of our mass to be what? To be capital M. Our velocity has been derived before, which is what? Which is LT minus 1. So the dimension of momentum equals MLT minus 1. And don't forget, our momentum is same thing as impulse, so they have the same dimension. So impulse equals momentum equals impulse, and they have the same dimension. Don't forget, once again, like our videos, subscribe till we meet in the next video. Thank you.